I'm Tom Bearden. I'm from Huntsville, Alabama. I have a master's degree in nuclear engineering from Georgia Institute of Technology. I have a BS in mathematics from Northeast Louisiana State with a minor in electronic engineering. Retired Lieutenant Colonel, U.S. Army. Basically, I do research and also theoretical research in over unity electromagnetic devices and also in some specialized medical treatment therapies.
How did you get started in the field of alternate energy technology?
We started in the field of alternate energy technology, of course, with this concern in the 70s. In the mid-70s, or early 70s, as you recall, we had quite a crisis in oil and energy and so forth, and particularly at that time, energy became uppermost in the minds of lots and lots of folks in the United States and actually throughout the Western world. We had been beginning in this area at that time, but at the time we also began to take a much greater and much stronger interest in what could be done about the provision of electrical energy. And so we really started very serious work at that time to look at electromagnetics, to look at the way you actually use electrical energy in an electric circuit, how you provide the energy to the circuit, where it gets the energy from, and if there's anything you can do to, number one, increase the energy, number two, get some for free, and number three, then use it to power a load so that you really could do it cheaper and cleaner.
Where did you get the ideas from that you're currently working on?
The current research that we're doing has really consumed almost 33 years total. We really started doing, at that time we didn't know you called it this, but we started doing what's called foundations work. That is, we look at the fundamental concepts that are being used in science and in electrodynamics, and we began to review, what does that really mean? What are you really talking about? What are you really doing? When we build these circuits or we build these devices and we power them, what happens? The problems we were running into is that the electrodynamic theory, electrical physics, part of it was put together over 100 years ago, the primary material. And since that 100 and something years, we've learned an awful lot more about the basics and the fundamentals. And it turns out along the way, lots of errors were made in founding the present electrodynamics. And certainly I'm not the first one ever to say that or point that out. Foundations scientists do that quite regularly. But it seemed to me that if you were going to try to build a system that could find a free energy source for itself, like putting a paddle wheel in a river or like putting a windmill to tap the wind energy, you had to find some flows of free energy electrically or electromagnetically, and you had to be able to extract the energy from that and use it. So we set about to see, what does modern physics say about how you get the energy in the electrodynamic circuits and how you actually can flow it over to the load and use it. We found that quite a few things that were taken for granted had long since been falsified, and that there were some holes in the theory. There were some free rivers of energy that one could begin to extract energy from. For a long time, we had a great deal of trouble identifying how in the world one would extract energy from the vacuum, when today the vacuum is known not to be an emptiness at all, but to be filled with enormous flows of energy flux. That work took many years to find exactly how to do that, and it turned out to be so simple that it's laughable. It's with ridiculous ease. A simple dipole, separation of two charges, which we use in every generator and battery and so forth that we make, already does that and extracts enormous amounts of energy. We found that a great portion of the energy that's actually extracted from the vacuum by our present systems had been discarded by the early theorists, that they had made mistakes in the interpretation of their own calculations. And so we pulled those out of the literature and we held them up and we said, if we correct this with what we know today, what's the new view? What's the new extended electrodynamics? It turns out that they had modified the equations which once prescribed systems which could run themselves. They were open systems, no different from a paddle in a river. But they threw that away and changed the equations without realizing what they had done. So we went back and finally found where they did that and how they did that and what had happened and what this had done to the design of systems. So then it gave us clues as to how to redesign the same systems in a totally different way, so that now we do use some of that excess energy we have available already in our systems. We no longer discard it. Then the problem became, well, how do you keep the system from destroying itself? Because ironically, we have been taught to build systems which, as fast as they open up a free extraction of energy, they use half of it to kill themselves again. So we got to put everything in. So we found out slowly and painfully how you do that. And so it was really a slow, painful process over a long number of years to finally have what we think, which we have presented at the present conference, the 4th International New Energy Conference, sponsored by the Academy of New Energy. We have finally presented what we think is the beginning theory of legitimate over-unity electromagnetic devices. In this field today, the term zero-point energy is much in vogue. What has been found out over the last several decades, particularly in physics, is that the vacuum, the emptiness in front of you, when you remove the air from it and just look at the emptiness, is not really an emptiness at all. As a matter of fact, it's filled with enormous amounts of energy, but of a very peculiar nature. Little particles, real particles, appear suddenly out of nowhere. It's called the Heisenberg uncertainty principle. And then they disappear just as rapidly as they appeared, forever. So we have matter actually being continually created and destroyed, appearing and disappearing right in front of our eyes. Hotter than a firecracker the tiny moment that it exists, but such an incredibly tiny moment you can't see it, touch it, taste it, or feel it. On the other hand, so there are so many numbers of them appearing so rapidly that they bombard matter, mass, and they create all the fields and drive all the mass, and they perform all the energetic functions of all the atoms and all the molecules and everything. So what we really exist is really in an open system which is driving everything, and everything else is exchanging energy violently with it all the time, and is trying to stay in equilibrium with it, but it's driving it all the time. So we found out that we lived in an incredible ocean of energy. So that's now well accepted in physics, proven experimentally and theoretically. And so now the problem is, fine, if we've got all this energy here, but it's this peculiar stuff, how in the world do we detect it? How do we actually extract some and use it? Well, the old school said, oh no, you can't do that. If you could, we'd have done it a long time ago. Well, what's happened is we found out you can do it. But what's happened is how to do these kinds of things was split across several different disciplines in physics. The electrical theory and practice that we use is very old. It was started basically by Maxwell. Maxwell is the first one we want to go to. During the time of the American Civil War. None of this stuff was known at that time. And so the ideas and the concepts that they use to develop the theory and the practices of electrical engineering today are very seriously flawed. And they do not match our modern physics knowledge from the various schools of physics, like particle physics, quantum mechanics, and so forth. And so what we've been doing is really interdisciplinary work. We've been looking at what we know for sure that we've discovered since the American Civil War, for example, and particularly since 1900, in these various disciplines that says we ought to correct electromagnetics. Because what we're looking for is, we're looking at how to put the oil well into the ground and get the gusher. Once we get the gusher, then we've got to figure out how to make the barrels to catch the energy and then take it to the load and dump it there. And that's an analog. But of course, it turns out that you can do that. And it turns out you can actually get the energy out of there. Then you've got the problem of collecting it and using it. With our work, particularly during the last 2 years, we have found that there's absolutely no problem in getting the energy out. All you want anywhere in the universe, from any point in the universe, you can extract as much energy as you wish. The problem is, how do you catch it and how to get it in the bucket, so to speak, to collect it so that you can use it. That's the real problem. And so our work, particularly during the last few years, is being, how do we catch it and then how do we use it? So, you know, I would like to power my home off of it, for example, and run my automobile. So that's the end goal, cheap, clean energy sources for all humanity.
Someone?
Yes, there's several major errors that are of particular use to us in what we're trying to do. One of the first ones is the fact that when you pull out the energy from the vacuum and run it down a wire, the energy fills all the space around the wire, enormous energy. We only collect a little tiny bit of it down on the wire. And what they did, they simply discarded all the rest of the energy and didn't try to do anything with it or collect it. Well, we think if it's a gusher full of energy and a river full of energy, we ought to put a paddle wheel in it and we ought to collect it. So that was a big help to find out that they had discarded an enormous flow of energy that was very useful and could be collected and could be used. That was a technical correction. Another correction was what you pay the power company for is not one copper penny to furnish all the energy that powers the city of Denver, for example, where we're sitting. What you pay the power company for is to pump electrons back through the return line, back into their generator, and fight their own generator. You create them to make, in essence, two great big elephants struggling against each other inside the generator and stomping and snorting and continuing to kill the very flow of energy that they're trying to get. So we got to quit doing that.
Wait a minute.
One of the things we're working on is trying to make a different kind of communication system. In electromagnetics, there's two components of the field when you start out with. One is what we call transverse. In other words, it's like the surface waves on an ocean. The water has to rear up and fall back down to make the waves. And so the waves travel very slowly in general on the surface of the ocean. Underneath the ocean is a different kind of wave. A little pressure appears, a sudden squeeze under there on the water. And that pressure is transmitted very rapidly through the water without making any surface waves. So that's an analogy. There are two such waves as that in electrodynamics. The interesting thing is, if you could keep this internal or longitudinal wave, if you could use it, it can travel at any velocity. It's not limited to the speed of light. So what we try to do is we try to kill the surface wave and use the internal wave and therefore communicate faster than the speed of light.
Okay, I'm interrupting here. I'm going to try to get a little bit better cropping. I'm back enough so I can see both of your hands. I was wondering if you're good with your hands in talking. I was wondering if you could do that again, but use some gestures.
Sure, no problem.
All right, let's because this is the perfect opportunity.
Okay.
All right, let's go with that one more time.
You want to run that whole thing by?
Yeah, let's ready, take two.
One of the things we're trying to do is a different form of communication electromagnetically. When you start with an electromagnetic field, one of the things you have is you have two components. You have a set of surface waves where the water has to rear up and down. Now, by and large, that set of waves on the ocean doesn't move very fast. That's one kind of wave on the ocean. But underneath you have this other wave, a pressure wave, that moves longitudinally through the water. If you put a sudden pressure under the water, it moves very rapidly, much faster than the surface wave. In electrodynamics, you have the same thing. If you could keep this inner wave, this longitudinal wave, it is capable of moving far faster than the speed of light, in fact, even with infinite velocity. But if you make the surface wave, you kill the inside wave, and you can only move at the speed of light. So our approach has been, let's find out how to stop the surface wave. Let's retain the longitudinal wave, and then we can communicate across the universe almost instantly. Certainly, for example, if we were using communication to a NASA piece of equipment, over by Mars or something, we wouldn't have this huge delay coming back. We could have a robot crawling around on Mars, and the communication with it would be instantaneous, no time delay. In the theory we've been trying to develop to explain how you can legitimately build systems that run their load and power themselves, taking the energy out of the vacuum, we have had to go back to Maxwell, to the very beginning, because it appears that this was in the equations to begin with. Then we had to track slowly and find out what changes had been done to those equations. One of the things, they changed the whole algebra, the whole mathematics that you use, from quaternions to vectors. The next thing we found is even after they had the vector equations, much more limited, a lot fewer things you could do with it, then we found that they even changed those equations. And so we had to unsnarl a trail a theoretical trail that went back over 100 years ago, and everybody has forgotten what happened. Well, after enough work, we found out what happened. And then we did just like you do when you try to untie a knot. We unsnarled it and took it apart and put it back together without the knot. One of the mistakes we found, there's nothing wrong with the procedure, but what they interpreted to be was a serious error. Lorentz did a calculation or a little procedure mathematically to extract only the little tiny amount of the energy flow that the circuit manages to catch. In other words, how much water you get in a bucket when you dip it in the river. And he did this little procedure which would give you that amount of energy out of the total amount available. And of course, that's how much you actually got to power your circuit. Nothing wrong with that as long as you don't throw away the rest of it. But what happened is, Lorentz then argued, falsely and wrongly, that the rest of it didn't have any physical significance. Well, now, of course, it did. If you stick some more collectors, some more buckets out there, you can collect some more energy to use for free. You already got the river. So what happened was, there came to be the belief that this little simple procedure gave you all the energy there was that you had extracted from the vacuum, a very major error. Today we know that in the average case you get about 10 to the 13th as much as this procedure yields. So what we discovered was there was already an enormous amount of extra excess energy coming down the circuit that you could collect from and get some more energy to use, almost as much as you wish. Early on, I was influenced very strongly by some of the early pioneers, and I'd like to give credit to them, full credit. First was Nikola Tesla. To my amazement, Tesla had made statements that the present electrodynamics was thoroughly fouled up. I couldn't believe that. I later came to believe it when I began to find the errors. Another major influence was the fact that T. Henry Morey in Salt Lake City, without any question whatsoever, made a legitimate device which put out 50 kilowatts of power right out of the so-called thin air. In other words, it extracted the energy from the vacuum. And he was probably the single greatest early pioneer in free energy devices that we ever produced here in America, or maybe anywhere in the world. And of course, for both men that I mentioned, both pioneers, we know that they wound up getting very thoroughly suppressed. Tesla, for example, lost all his funding, was never able to get it again. And so then T. Henry Morey could never get adequate or straight funding. Actually, the Morey family put a rather enormous amount of their own money at the time in the device. And what was really sad is the American scientific community did not pay proper attention to either pioneer. With respect to Tesla, we know many things that he spoke of, particularly once he was suppressed. He began to talk about some of the things he had done that were more spectacular. And one of those was, of course, the transmission of energy without wires. Now, here we have to be very careful because he had two different kinds of things that occurred at two different times. One of them was his particle beam, that he discovered how to fire a beam of very intense particles, which was way ahead of his time, but that was the later development. The first development was how to actually transfer energy through the air as if it were going down a set of wires, but with only one wire there. That was his single wire transmission system. And then later he actually outgrew the wire. So Tesla really had several different systems for transferring energy. He also experimented with systems which were not necessarily limited to the speed of light. He was adamant that the wave he was using was a longitudinal wave, which is intriguing since it's very close to the same thing we're trying to do today. T. Henry Morey demonstrated dozens and dozens and dozens of times this beautiful developments that he had made. He was suppressed by actually an agent being planted in his lab, probably a double agent, apparently worked for both an American agency and also the Russians. He was shot at on the streets. He had to ride in a bulletproof car. He was shot in his lab, physically shot. The Russians tried to kidnap him once in New York City, almost like a dime store novel, every bit true. T. Henry Morway was never able to get the American scientific community to pick up on the great achievement he had made. And so when he passed away, by that moment it had been lost in history. His son John Morey has tried very hard all through the years to get the funding to get started again. Never been able to do so. So we lost a legitimate free energy device of great importance when we lost that Morey device. We lost a great genius, and a great production could have come from Tesla when Tesla was suppressed. Well, we're asked many times about present status as far as lots of inventors are working real hard on the problem, lots of scientists are. Often we're asked who's the most important. I really think that all of them are important. There are many approaches to the problem. It's like, what kind of car do you build? Well, there's lots of kinds of cars you build. You want to build some golf carts? What we need is we need the richness of many approaches, many different minds, many different sets of experiments, many directions, because basically we're trying to work towards a totally new technology. It's not one that's in your textbook. It's not one that we know how every facet and every bit of the phenomenon and everything. It's not that simple. Basically, we're trying to work into a totally new technology, one that's not in the textbooks, one that's not taught at a university, one that nobody knows everything about at all. We're just exploring and discovering. So we need as many explorers and discoverers as we can get. And one of the things we really need serious scientific work on the theoretical aspects, on how to create a model which says, number one, we're consistent with physics and thermodynamics. Number two, you can in fact extract the energy, and you can in fact use it. And number three, you can keep from killing the thing that's extracting the energy, and you can keep it going like a flowing river. A lot of work has already been done. I might mention, for example, Puthoff and his colleague, who actually showed thermodynamically there's no reason thermodynamically why you can't extract the energy. What this means in layman's terms is, yeah, you can get the energy. Physics says it's okay. And so we now have one big okay that's been done with theoretical work. We know we can get the energy. I think one of the contributions I've tried to make, it's not my original work, I just found it over in particle physics. And I found that particle physics already solved a big problem and said, yeah, here's the way you get it. Here's what produces the gusher or the river. The third part that we need is, now that we got the river, now that we got the excess energy, now that we got an open system, now how do we make the paddle wheel? How do we make the water wheel? How do we tap it and use it? And that's where the work should be concentrated now. I would even make a fervent plea that our Department of Energy focus on the work, because the basic theory to provide the river, guarantee we have the energy available to use, is already accomplished. I think they ought to get in the act, and they ought to fund some very serious work in how do we now collect the energy and use it. We'll do that, there will never be another energy problem in the world till the end of time. In our own case, we're tackling the problem now that we have the river. We have scientific assurance that we haven't violated any laws of physics. It's not perpetual motion. It's absolutely permitted by physics and by everything we know. We have the energy flow guaranteed. So we have focused all of our work on electric circuits. Lots of folks are working on motors, lots of folks on generators. We're focusing on electric circuits. And what we're focusing on is what happens to the energy flow in a circuit. How do we collect it, and then how do we use it? We found this Lorentz thing which showed that they didn't even focus on the energy flow. They only focused on the tiny bit that you got and collected. Now let me give you an analogy for what I'm talking about. Suppose you built a water wheel, and suppose you had a little gate with a little ditch to feed the water to there, and you opened a little gate onto this big river next to you here. A little stream of water now is gated out and comes across the water wheel. You wouldn't say that the only water that's around here and the only energy that's around here is just the water flowing in that little ditch. I mean, that's very foolish. And yet that's exactly what electrodynamics did. They misinterpreted it. Make the little trick to figure out how much water you got in the ditch. but don't throw away the river. So what we've done is we went back and got the river and put it back in the problem. And we are now tracking the excess energy, and we're designing collectors to go collect some more of that excess energy, get some more sluice gates, get some more water wheels. Another strange thing we found, or rather realized, it's already in physics. It just seems that we haven't realized it in electrical circuits. You can reuse the same energy over and over again. The fundamental law of energy is that energy can neither be created nor destroyed. When you so-called use energy to do work, you don't use it up at all. You deflect it, diverge it, change its direction, or change its form. But when you get through doing the work, you still have all the energy you started with. What you can do is you can just bring it back around, run it through again, and use it again. To be a little more technical about it, you can retro-reflect it, which means reflect it back to where it came from. That can be done. And when you do it, you pass it back through, collect some more, do some more work. There is absolutely no limit in nature to how often and how many times you can use 1 joule of energy. You can get 1,000,000 joules of work out of it if you have the properly designed system. Nature has been doing it ever since the Big Bang theory. Big Bang that started, they think, the universe. And so we've just realized you can do it in electric circuits. And so what we want to do is, and are doing, is using the energy and doing the work, but not letting it get away. We don't let it escape on out into space and leave us. We reflect it, bring it back, run it through again. Actually, the thing that's called anti-Stokes emission has already been known in the physics, in the ordinary literature, for 30 years. And it's always more energy out than you got to put in to run the thing. Recently, there have been some important scientific work in that area. I'd like to mention the Lawande experiment, which is written up in Nature, which any sophomore in physics or electrical engineering in any university or college can do. Cheap, works every time, always gives you more energy out than you get. Lawande has filed some very fundamental patents on what's called lasing without population inversion, and that's the process. But it is an over-unity process. It proves the principle. It does what we say, you only have to have one white crow to prove that not all crows are black. And when you take the Patterson effect, which is actually an adaptation in my view, it's a special adaptation of the anti-Stokes emission phenomena and a very clever use of it. When you add the Patterson effect, which is validated, then you have the absolute proof that it's possible to build over-unity systems that put out a lot more energy and power a lot bigger load than the little bit of energy you got to put in to run them. We're often asked, for example, about our own patent efforts. We have filed so far 3 patent applications. They are not granted, they are patent pending. We have many claims in the field of circuits on these 3 patent applications. And we are claiming over unity, and we're claiming it is not perpetual motion, it's absolutely permissible, and we're explaining why it is, and we're citing chapter and verse that proves it is. So we're very encouraged by this because we think eventually we will get our patents. The other thing we're doing is we're preparing 2 more patent applications at the present time. One of them is for the beginning, the initial part of a superluminal communication system, a system that does use the longitudinal wave I was talking about and is capable of communicating faster than the speed of light. Now here I'd like to add one thing. The proof that you can communicate signals faster than the speed of light is already there and it's already accepted. It's called quantum tunneling. Both theoretically and experimentally, you can, and they have, transmitted actual signals faster than the speed of light, and it's written up in the hard literature. For example, they transmitted in a waveguide between 2 points one of Beethoven's symphonies over 4 times the speed of light, and that's hard physics and it's been replicated. You can bank on it. What we've done that's different, and it's quite different from what they're doing, they're using a quantum process. We're using something totally different. We're using a wave process. We are using a wave that really is a macroscopic tunneling, a large effect tunneling, rather than a tiny little microscopic effect down through the waveguide. So we have a different system, we achieve the same result. In our case, we have a small company called CTEC Incorporated. We are an Alabama corporation, duly incorporated. We've been in business now for several years. We do not sell stock. We do not look for investment capital. We are simply out of our own hides and our own pockets proceeding to do experimental work in our own little laboratory, and it's a small one, on our own applications, our own approach to over-unity circuits. Now, we've had very encouraging results, but I will tell you the honest truth. At the present moment, we do not have a working model. As early as 1990, we were blowing up circuits from the excess energy. We could not control it in the semiconductors arrays that we were using because they simply ping-ponged the energy back and forth between them, and one would get such a surge of energy it would simply blow off the board. We know how to control it. We know what has to be done. We certainly don't have the tremendous laboratory and a pretty sophisticated team that it would take to do that. So we have that one on hold. And notice I haven't told you anything about how to do it, just what we were doing. But we had over-unity results as early as 1990, early on. Since then, we've turned to other means to do it. One of the means was to use a very highly specialized material. We came to call this material unobtainium because it was so hard to build. Since it became a tremendous metallurgical problem to even build the material to have any, that again came beyond our present capabilities. So we put it on hold until we have that kind of metallurgical capability sometime in the future. Presently, we have pursued additional areas that I spoke of how to collect the additional energy. Specifically, we are using multiple passes of the same energy. We're reusing it over and over again. We're collecting from it again and again using retroreflection in electric circuits. We are extremely close at the present time to working models, and that's really all I can say about it. I've given you what we're doing. We have very encouraging results. We have some more work to do. I might add that one of the areas we're often asked about is, what's your projection for the future, particularly in the field of free energy here we're talking about? Our projection is that in 2 years, you're going to see commercial over-unity devices on the market. Now, the first ones probably are not going to be from us, C-Tech. You're certainly going to see versions of Patterson's equipment and processes and devices on the market. You are going to see something out of Lawande's approach on the market. There are several other inventors that I don't follow their work that closely, that I think you're going to see. I think you're going to see Dr. Correa's work together with his colleague, his wife. I think you will see the Correa work coming to the market. I think there are several other very encouraging systems and devices and work going on right now that are going to see the market beginning in about 2 years. By the time you get 5 years down the road, everything is going to be in a mad scramble to go to systems which put out lots more energy than you got to feed them. We're going to see substantial changes in the furnishing of power to your homes. If we go down 10 to 15 years away, you're going to see this kind of system. You're going to see a small card just like this, with chip technology, with an array of semiconductors, with the stuff we've parked right now, but we will pick up in the future. You will see a chip this size that you plug in a little slot in the wall in your home, and that furnishes the power in your home until something breaks. You will see another chip, not too much different in size, looks the same, that you plug in your automobile, and you don't have to pass the gasoline station. Now, they're going to have to find a way to tax you on this little card, which they're going to do. But definitely in our future, we are going to eliminate the energy problem for all time. We're working on, at the present time, 2 books with enormous labor. We are very close to finishing the first one, which we hope to deliver to the publisher in June, which will then require a few more months for publishing. It deals with the priori device and the priori process that was funded by the French government in the early 60s and 70s, which does give you a mechanism for curing just about any kind of disease you want to talk about. In laboratory animals, eminent scientists in France, it's all in the hard literature, were able to cure terminal tumors in lab animals. They were able to cure arteriosclerosis, clogged arteries, which is a great problem, for example, in our countries. Many other diseases they demonstrated. It was spectacular work, unheard of work. almost called a miracle. It used a completely different approach. What it really did, by a special form of electrodynamics, which is what we've been working on, it was able to take a single cell or every cell in the body and back it up in time. We call it phase conjugation. Biology calls it dedifferentiation. What you really mean is back it up to a previous form and state where it was a healthy cell. And you do it genetics and all. Now, if you back up a tumor cell that came from a human normal cell, when you play back the television tape or the videotape, so to speak, you just run the cell back until it's a normal cell again. Now, what you do is the effect is amplified so it runs back quickly. It doesn't take another 5 years to get back there. By the way, this process is absolutely proven here in the United States by the eminent work of Dr. Robert Becker and some of his colleagues. Becker was nominated for a Nobel Prize for proving that little tiny DC potentials, laughably weak currents, picoamperes, could in fact do exactly that process with cells and their genetics. It could change them into entirely different kinds of cells. Let me explain. If you have a terrible bone fracture, what Becker and his colleagues found out was that a little tiny trickle current and a little tiny DC potential across that bone fracture would cause a most amazing thing, and this was Becker's work. The red blood cell, the red corpuscle, would come in. Exposed to this tiny, laughably weak potential, it would shuck its hemoglobin coat. It would grow a nucleus. It would turn back to the form of a cell much earlier, which we call dedifferentiation. It would then change forward to the kind of cell that makes cartilage. Well, that wasn't what was needed. It would change once again into a different cell, the kind that makes bone, deposit and heal the bone. Today, that process is approved and it's used throughout the United States in many hospitals. It is FDA approved. But the basic process is not used on other diseases, nor has it been explored. And what we've been doing is looking at the work in France, which did use the other parts of the process and could cure the other diseases, and we're putting that in a book for the whole world. I don't care if I make 1 cent on that. I want the world to know about it. For example, if you take a single AIDS cell and you back it up, genetics and all, you now have a cell which no longer has any HIV virus inside of it, and you solve the biggest problem in AIDS, the problem that your immune system cannot attack. The second book that we have in the works, and it's about half finished, we expect to deliver it in the late fall to the publisher, which means it's probably going to be early next year when it comes out. This will contain, I think, what will be the beginning of the world's first legitimate theory of over-unity electromagnetic engines, circuits, and devices. In there, we will release a certain thing that we have not yet released, the final little bitty secret, but it's real magic that you've got to do in your circuits that gives you over-unity. We plan to release it formally in that book. And so what we hope to do with the book, we're writing it so that the lay person can read it and get a lot out of it and understand it. We're writing it with 2 tongues, one technical, one common, ordinary English like I spoke as I grew up, you see, and I still speak whenever I lapse into the vernacular. So we're writing it in both fashions, and we're putting everything in it. We're not holding anything back. You will have then, we hope, something that not only does everybody then understand what's going on and understand how to go build these kinds of systems, but we also hope that the sharp young graduate students in university, the sharp young postdoctorates in university, and some of the professors will take a great interest in this, and we'll see absolutely a revolution in our science and technology. That's what we want. At the present time, the biggest obstacle to the advent of free energy systems has several prongs to it. It's really the mindset. Any large system, such as our present science is, has a mindset. And well-to-do. You don't just change science willy-nilly at the whim of anybody. You have to do a lot of hard work to change it. That's understood. You have to have working proof, experimental proof that it works. We have reached that threshold and passed it. You have to have some kind of at least an ad hoc model that explains how this thing works, that's scientific. We have crossed that threshold. So I think that we're going to start to pick up support in the scientific community. But here we have the same problem the cold fusion folks have. We have a tremendous juggernaut, a tremendous locomotive, a great big ship wallowing along with all its mass, and it just can't turn very quick. And so all the money, all the funding, all that controls what scientists do and all the universities and what the grad students do is all directed into other channels. Everything coming from Department of New Energy is going into something else. Everything that's coming from all the electrical research is going into something else. There's not a single program, well-funded program anywhere in this country that's funding these sharp young minds to go back and dig out what's wrong with electrodynamics and correct it. As a matter of fact, they take the other attitude. They beat them to death, figuratively speaking, if they try. So if we keep our sense of humor, what we've got to have is a change in the entire mindset of the scientific community. And we've got to get out of their mind any remnant of the fact that we're talking perpetual motion. We're not. This is hard, literal theory right out of the textbook, and it is permitted. So what we're hoping is that we have a point we reach at about 4 to 5 years from now where there's a tremendous switch in the scientific mind, and we will find the orthodox scientific community pouring tremendous funds in the entire area, and we'll find them leading. And I welcome that. I hope and I wish for the scientists to lead this entire area. Let's do it scientifically. Let's do it correct. Well, the greatest benefit for the entire free energy area, the most immediate benefit, is you can't change everything overnight. We're talking about a 20-year period in changing the power systems in a gradual kind of approach. We're talking about a 20-year program before you actually change all your automobiles and this kind of thing. But every change you make stops the pollution a little more in the cities, cleans up the biosphere a little more. You don't need the big nuclear power plants. You don't need to create all the nuclear waste. You don't need to burn all the fossil fuels. As that gradually declines, then we gradually clean up the biosphere. We restore this beautiful home of ours, this great shining blue planet that's so clearly shown in the NASA photos from space. We restore the Earth planet to literally Mother Earth. The greatest single benefit amongst the many benefits that will come from the use of what we're calling over-unity or free energy devices is that we're going to have a tremendous impact on the life of everybody on Earth. The greatest single benefit that's going to come from this impending new revolutionary change in energy, first, it's going to affect every person on Earth fairly quickly, but it's going to be a gradual evolution. We're talking about huge systems that have been accumulated over many, many years. It's going to take, say, 20 years before all the power systems really get changed, before all the automobiles really get changed, before the revolution is fully launched. It's going to be more like an evolution rather than a real revolution. And it's not going to displace huge industries. That's not what's going to happen. The power companies are going to use it to furnish power. And then gradually you're going to find distributed power systems, and gradually it's going to work into home power systems. That's years down the road for the small things like I showed. That's the size of a credit card. But it is going to penetrate to the ends of the earth, to the most remote regions, to the most remote villages, because it's going to be cheap and it's going to be easily portable, and you don't have to keep carrying fuel. Everybody is going to be able to go on an energy conference. As this evolution continues over, let's say, a 20-year period, you're going to find that every time you burn less fuel, you reduce the pollution of the atmosphere, you reduce the pollution in the cities, one more step down. Every time the more cars are changed to fully electric powered cars with no fuel power in the batteries or anything like that, no hidden combustion products, it reduces dramatically both the pollution in the cities and the biosphere. So gradually we're going to see the pollution coming down. We won't need the big nuclear power plants. We won't need to create all these nuclear byproducts. So we're going to see that pollution going down. And we're going to see eventually the restoration of this beautiful Earth planet of ours, so vividly seen in the NASA photos from space. We are going to see the Earth planet returned to our own true Mother Earth. That's sort of like a tax you put on yourself to fund that organization that does it separately. That's in our plans. I don't advertise that fact, but that's in our plans. If we ever make it, if we don't, it's just a dream. But if we do, that's what we're going to do.
So you would
The other thing is you can get into the longitudinal wave we're trying to use. That's the way we're doing. We're going down inside, and all we got left is the longitudinal wave. So we're already down in the water working. We're not wiggling around on the surface. So that's one thing we're trying to do, and you know, you can do that. And so it so dramatically extends electrodynamics, and then it suddenly ties in general relativity. Instead of talking about, to look at experiments in general relativity, I got to look at the star over there and see how, or the sun, see how the light bent and all that. You do it right there on the bench. Well, you see, that doesn't exist in general relativity right now. So you just sort of revolutionize general relativity, and you make it an engineering science, whereas now it's a theoretical science primarily. So almost exclusively. So you really get those guys by the nape of the neck and see the britches, and now they become experimentalists, you see. You have an explosive development right there. So everywhere you turn, when you extend dramatically one part of science, you just sort of grab up all kinds of things and carry it right along with you. And this is a revolution if we ever get it born. But it's going to take people with greater skills than I have. It's going to take a lot more than one people. I mean, I'm just one people. I'm not an electrodynamicist. I'm not a physicist. I'm a nuclear engineer who done a lot of hard work trying to find out what was wrong with that stuff. The only thing I can do is blow a hole in the wall. The beautiful job of cleaning it up, have this elegant engineering theory where you can engineer the equipment at will like we can today with the other stuff. That's going to take a whole team of people and lots of experimental work. That comes out of these young grad students and these young postdocs and doing their thesis and all this, you see. That's why we got to get the scientific community in it. We have a revolution, we've got to get it born.